Alright class, this is the last lesson for chapter 2. It's pretty much the same thing except for with word problems. Find the instantaneous rate of change. Again, the word instantaneous means we have to use our difference quotient to find the slope or how it's changing at one point. And at this point, it's t equals 2. Then it says interpret the answer if the value of the function is a position and that the object is at time t seconds. So we're doing position over time or distance over time, which is a velocity or a speed. So anyway, we can find the difference quotient, limit as h approaches 0 of f of t plus h minus f of t all over h. So if I start subbing in, well, what is f of t plus h? That's the function when you put a t plus h in instead of a t. So I have 2 and I'm putting a t plus h squared minus 1 minus the function, which is 2 times t squared minus 1. Again, you could have put 2 in for t at this point, but we can do that later as well. Doesn't matter. I guess I just tend to do this more often. So I get t squared plus 2th plus h squared minus 1 minus 2t squared plus 1 all over h. The limit as h approaches 0 of 2t squared plus 4th plus h squared minus 1 minus 2t squared plus 1 all over h. I can cancel out the 2t squareds because they add and subtract to 0, and same with the negative and positive 1. So I'm left with, and then these things I can cancel an h out of, so I'm left with the limit as h approaches 0 of 4t plus h. So when h goes to 0, we get that. We have 4t. So this is the rate of change. However, it says at t equals 2, so at t equals 2, we get a rate of change of 8. And then again, if it's in feet, yes, in feet, it's 8 feet per second. Okay, so that is an instantaneous rate of change. Again, it's more of a review, but it's good to look at a couple extra problems. We can even do this with geometry formulas. First off, it says we want to know what the change of volume is with respect volume of a sphere with respect to the radius. So we know that the volume equation, or we should know that the volume equation of a sphere is 4/3 pi r cubed. So I want to know how this is changing with respect to r. So r is my x value, v is my y variable, or my function. So really what I'm looking for is change in v over change in r. Another way to write that is dv over dr. We're going to use this notation a little bit down the line. I know you haven't seen it yet. But basically we're looking for that, and to do that we have to, again, use our difference quotient. So the limit as h goes to 0 of 4/3 pi r plus h cubed minus 4/3 pi r cubed all over h. Now, to expand this, hopefully you guys remember that expansion. If not, you can just multiply it out 3 times. It's a lot of time, but it is possible to do it that way if you do not remember your expansion. 4/3 pi, and then this becomes r cubed plus the number from Pascal's triangle, or for 3 combination 1, or the combination of 3 choose 1, would be 3, and then r goes down a power, h goes up a power. We have another 3, r goes down a power, h goes up a power, and then it goes back to 1, and then it's h goes up a power, r goes away. Minus 4/3 pi r cubed all over h. So I'm going to simplify that. The limit as h approaches 0 of 4/3 pi r cubed plus 4 pi r squared h plus 4 pi rh squared plus 4/3 pi h cubed minus 4/3 pi r squared all over h. So again, as every other example with the difference quotient, the originals will cancel out and you're left with all the pieces that have h in them. and we can divide everything by h, and we get the limit as h approaches 0 of 4 pi r squared. This one has an h still, 4 pi r h, and this other one has h squared. Okay, plug 0 in, this goes away, that goes away, you're left with just 4 pi r squared. This is the rate of change, the instantaneous rate of change of the volume with respect to the radius at whatever point you want. And then we do want a certain point. It says when the radius is 2 inches, so we're going to plug that in, and you get 16 pi. The units for this are a little weird because I know you guys like to simplify, but just look at what we are changing. The units for volume, when it's inches cubed. So it's 16 pi inches cubed over what's changing, the radius. The radius is just in inches. Yeah, I don't want you to make that inches squared. It's just because this is a ratio to tell you it's inches cubed per inch radius. These are attached to different things. So that is the final answer, and that is it for 2.4.